In this video, we're going to be going through the Algebra 2 midterm exam review for the first semester of Algebra 2. So I put together 62 different types of problems, over 100 plus examples in this video. And in the description below, if you go down there, I've got timestamps that will take you directly to any particular problem that you want to focus on. So let's get into this video. Question number 1, it says write the numbers in increasing order. This is a typical problem that you see on a first semester exam. And basically what the key is to this problem, in my opinion, to make it easier, is to convert these into decimals. This makes it easier for you to compare them. So what I'm going to do is I'm just going to convert these into decimals. We know that pi is 3.14. So I'm just going to put it right below it. We know that negative 4.7 is already a decimal. Okay, square root of 37, I'm going to go to the calculator and get an approximation for that one. Okay, so that looks like it's about 6.1 if we round. Okay, 6.1. And then 36 fifths, again, we can take 36 divided by 5, and we've got 7.2. So here it says, write the numbers in increasing order. Sometimes it'll say decreasing order. So increasing order, we want to go from the lowest to the highest. So you can see negative 4.7 is the lowest. Okay, so we'll put that first. The next one, as you go along the number line, remember from negative to positive and zeros in the middle, right? So the next smallest one is going to be 3.14, but instead of writing 3.14, you want to write pi, okay, just like in the same form that they gave it to you. And then the next one after that looks like it's going to be 6.1, which is the square root of 37. And then after that, that's going to be 7.2, which in this case, they're giving it to us as a fraction, 36 fifths. So that's question number 1. Now, what you might want to do as you go through this video course is pause the video, okay, see if you can do the problem on your own first, and then we can go through it together. You might get more out of it that way. Okay, now example number 2 here, it says, if you bike 20 miles per hour, what is your speed in feet per second? Okay, so this is a good question here, and basically what they're testing us on in this problem is, can we convert from miles per hour to feet per second? So let's see what we have here. Let's start off with the 20 miles per 1 hour. Per means divided by the way. And we're going to convert that into feet per second. So let's see. So for every mile, 1 mile is equal to 5,280 feet. See, this way the miles cancel, numerator and denominator, and we've got feet per hour, but we actually want feet per second. Now, we know that there's 3,600 seconds in 1 hour, right? So this way the hours cancel, again, numerator and denominator, and what we have is feet per second, or feet divided by seconds, which is what we want. So what we're going to do now is I'm going to multiply all the numerators together, all the denominators together, and I'm going to divide, okay? And that's how we're going to get our answers. So if we do that, I'm going to go to the calculator, 20 times 5,280, right? Okay, and then I'm going to divide that by 1 times 3,600, which just comes out to 3,600, and that comes out to 29.33. I'm just going to round it to 29.3, repeating feet per second. Okay, so you're with me so far? So let's go to number 3 now. It says evaluate. This is a 4-part question. And what they're testing us on in this question is, do we know the order of operations, the PEMDAS? Remember the please excuse my dear Aunt Sally? So what we have here is we've got negative 3 to the 4th, but notice that that's in parentheses. We have to take it as a group. It's actually negative 3 times negative 3 times negative 3 times negative 3, see, 4 times. If we have 4 negatives multiplied together, that gives us what? A positive, right? So an even number of negatives is positive. So this is really going to be positive 81. Okay, now the second part, negative 3 to the 4th, a lot of students will get confused on this because they don't realize you have to do the exponents here first and then multiply by the negative second. So parentheses first, exponent second, multiplication third. So 3 to the 4th is 81, then times the negative, that gives us negative 81. Letter C here, negative 3 to the 3rd power, again, same thing, 3 cubed is 27, 3 times 3 times 3, so that's negative 27. And then the last one, you can see we've got negative 3 cubed, but what's different about this problem is we've got negative 3 times, right, 3 times, but when you have a negative times a negative times a negative, an odd number of negatives, you get a negative. So this is going to work out to negative 27. Okay, so good question, order of operations. Number 4, it says evaluate, which means find the value, right, of this expression here when y equals negative 3. So all they're really telling us here is, this is just a typical substitution problem. We want to put negative 3 in wherever we see y. Now when you do these substitution problems, I recommend putting it in parentheses so it takes it as a group, okay? So you take it as a group, or if you put it in your calculator takes it as a group, okay? Otherwise, you know, you can get the wrong answer if you do it without having the parentheses. So let's focus on the order of operations like we did up here. -3 squared is a positive 9 because you have two negatives. So this is really 9, okay? And then over here we've got a -3 times a -3, which is a positive 9. See, when you see minus, you can think of that as a negative number. So negative times a negative is a positive, and then plus 2. Now -2 times 9 is -18, okay? And then you can see that 9 and 2 is 11. So we have a -18 plus 11, which is a -7, and you got it. Okay, question number 5 says you're starting a tutoring business. It costs you $400 in startup costs and you charge $60 per session. Write a profit equation given the number of T sessions. And then part B says calculate the profit after 30 sessions. Okay, this is a typical problem, and what they're testing us on here is slope-intercept form. So remember, slope-intercept form is the y equals mx plus b form of a line. And you can see what's happening here is that the m is the slope or the rate. And in this case, you know, this person's charging $60 per session. So 60 times the number of sessions, you know, T sessions. And then B, that's the y-intercept, but that's in a story problem, that's the initial condition or the starting amount. In this case, the starting amount is that it's $400. So in this case, we're going to think of that as a -400 because, you know, your startup cost is a negative. You haven't made any profit. So basically what we have here is we have profit. Okay, the output is the number of tutoring sessions times 60 minus the $400 for the initial startup costs. So that's your equation there, y equals mx plus b. Part B says calculate the profit after 30 sessions. So all we have to do here is put 30 in place of t. So if we do that, 60 times 30 is 1,800 minus the 400, and you can see that's going to be $1,400. Remember your units for word problems, right? So let's go to number 6. So it says solve these two equations, okay, a and b. So a lot of times students freak out when they see all these fractions. They say, oh, I hate fractions. But what you can do is you can clear the denominators, okay? This is a great technique. And what you do to clear denominators, you can think of any whole number as a fraction by putting it over 1. And then what you do is you look at all the denominators and you say, what's the lowest common denominator? Meaning, what's the smallest number that 3 divides into, 5 divides into, and 1 divides into? And in this case, you can see that's going to be 15. They all go into 15 evenly. So then what you do is you multiply everything in the equation by 15, left and right sides. It keeps the equation balanced. And what happens is, see, 15 divided by 3 is 5, times 1 is going to be 5, and that's x. Now, if this is a little bit confusing, what you can do is right next to the 1/3, put 15 over 1. And then what you can do is you can cross-reduce like that. The 1 and the 5 are right next to each other, so they're multiplied together. That's how I get the 5x. Same thing here. Or if you don't want to do that, you can just say 15 times 2 is 30, divided by 5 is 6. And then over here, same thing, 15 times 5 is 75. The other way to think about it is when you're multiplying fractions, you multiply the numerators together and the denominators together. Okay, so continuing on, we get 11x equals 75. Divide both sides by 11, you can see that's going to be 75 elevenths, and we got it. Okay, let's go to part B now. This one here, what it's testing us on is the distributive property. And here's where students go a little bit off. When they see this minus sign, okay, they get a little bit confused about what to do. Do I distribute the 2 and then subtract? Or do I distribute -2? What I like to do is just think of whenever I see a minus sign, I like to think of it as a negative number. And so then I just distribute the negative number. So this is going to be 4. -2 times 5y is -10y. And a -2 times a, see, -3, I'm capturing that sign. I get a positive 6 equals 30. So now all I have to do is combine like terms. That's -10y plus 10 equals 30. Subtract 10 from both sides, we get 20. And divide everything by -10, and you can see y is equal to -2. Now, you can always check your answer if you put the -2 back in and make sure you get 30 and you know you've got it right. So let's go to number 7. So I hope you're enjoying this course so far. If you are, subscribe to the channel. And again, remember, if any of these problems are difficult, go to my Mario's Math Tutoring YouTube channel, go to that little search icon on the channel. It's a little bit further down on the page, and type in, you know, how do I work with fractions? And, you know, it'll bring up those videos that are related to these topics. So number 7 says it takes you 25 minutes to paint a fence and your brother 75 minutes to paint a fence. How long will it take if you work together? Okay, so teamwork, right? This is what they call a combined rate problem, okay? And the idea here is that in 1 minute, you paint 1/25 of the fence, okay? Times the number of minutes tells you how much of the fence you've completely painted, right? So 4 minutes go by, you've painted 4/25 of the fence, and so on. So if we go to your brother now, your brother is painting 1/75 of the fence times the number of minutes that he works, and together you're trying to paint one whole complete fence. Now if it was 2 fences, I would make this equal to 2. But the key is rate times time plus rate times time equals the total, okay? And so what I'm going to do now is just like what we did up with this problem here, is we're going to clear the denominators, okay, because maybe we don't want to work with the fractions. The common denominator is 75. I'm going to multiply everything by 75, left, middle, and right, okay, the whole thing. So if I do that, that's going to give us 3t plus 1t equals 75. So 4t is equal to 75. And if we divide by 4, I'm just going to go to the calculator to get an approximation on that. That's going to be what? 75 divided by 4, 18.75 minutes is what you should get for this one. Okay, 18.75 minutes. Okay, now let's go to number 8. It says solve for m. Okay, now this is a typical problem, but what makes this a little bit more challenging, this problem, is that there's an m in this term and there's an m in this term. So how do we get the m by itself? Because when you want to solve for a variable, you want to isolate the variable, right? Well, the key here is to do the distributive property, like we were talking about in this problem, but backwards. You're trying to factor out the m. So I'm dividing out m out of this group and m out of this group, which leaves us with 3n minus 9 equals 12. Then all we have to do is, instead of multiplying by 3n minus 9, let's divide both sides by 3n minus 9, and that's it. So you can see m is equal to 12 divided by 3n minus 9. So if you're enjoying this video, again, you can go down to the description and click on any of the timestamps to take you to a particular video if there's problems you want to focus on more. But otherwise, let's go to the next question. Okay, number 9, it says write a function that represents the table values. Okay, and so you can see this XY table here. Well, the thing that you want to recognize here is the change in Y, okay, and the change in X. Okay, the change in the Y values, the change in the X values. You can see that the Y values are going down by 5 each time, right? And as the X values are going up by 1 each time. Okay, so what that tells us is, it tells us that the change in y over the change in x, which remember is the slope, is a -5 over +1, which is -5. So that's our slope. And our initial condition, or our y-intercept, is going to be this key point right here. When x is 0, that's the starting point. That's the b value in our slope-intercept form, y equals mx plus b. So in this case, we have a slope of -5, but the y-intercept is +20. Now the nice thing about this is you can check your answer. So I could say, like, say for example, x is 3, that's -15 plus 20. Yep, that gives us an output of 5. Okay, so slope-intercept form again. Now number 10, it says graph on a number line these two inequalities. Okay, well let's start with this one first. Now this is called a compound inequality, and the key here is, okay, you want to graph this on a number line. You want to put the smaller number on the left, the larger number on the right. So here's -2, 0 somewhere here in the middle, here's +5. But you can see that x is sandwiched in between -2 and 5. It's greater than -2, okay, but not equal to, so that's going to be an open circle. And x is less than or equal to 5. Okay, so equal to means it includes that point, and you're in between those two values. Okay, so you're with me? Now part B, it says x is less than or equal to -3. So here's -3. Less than or equal to means it includes that point because of the equal sign. Less than means smaller or to the left. Or x is greater than 5, but not equal to. So greater than means that it's open. It doesn't include that point. Or greater includes the points to the right of 5. So that's graphing on the number line. If you're preparing for the ACT or the SAT, check out my 2 courses that I put together for you. One's called the Huge ACT Math Review video course. The other one's called the Huge SAT Math Review video course. And a lot of students have taken them so far. They've been able to boost their scores. There's a teaching section. We go through example problems together to help students understand the underlying concepts and see typical type problems. We go through formulas and ways to approach the problems so that they can maximize their math section score. So check those out. But let's continue on to question number 11 here. These are absolute value problems. So a lot of times these stump students, okay, and students get these problems wrong when they go to take the midterm because they just forget how it works. And so let me see if I can kind of explain this to you. the idea here is that we've got an equal, we've got a less than, we've got a greater than. So when it's equal to, what this really means is it means the distance between some number and 2 is 5 units, right? It means it could be 5 units smaller, it could be 5 units greater, okay? It's basically saying the distance is going to be 5 units away. So if you go to the number line, see here's 2. It could be 5 units greater, it could be over here at 7, or it could be 5 units less, it could be here at -3. So these are our two answers, and you can put those in. -3 minus 2 is -5, take the absolute value, that's 5. Same thing with 7, 7 minus 2, take the absolute value, that's 5. But a lot of times students want to know, how do I actually set up the problem? And what I would do is I would write two equations. I'd say x minus 2 equals +5, or x minus 2 equals -5. So when you think of the absolute value, what it's saying is the distance from 0. Okay, it could be to the left, it could be to the right. So all we have to do now is add 2 to both sides, we get 7. Add 2 to both sides, we get -3. Same thing as in this geometric way of solving it. Okay, part B though, this is a less than problem. And what this is telling us is that this value has to be smaller than 5. Okay, and so what we can do with a problem like this when it's less than is we can write it as a compound inequality. What you do is you say 3x minus 1 is less than 5, and it's greater than -5. So you take whatever's in the absolute value, you put it in between the negative quantity and the positive quantity, and then all I have to do is solve this compound inequality. And the way I would do that is I'd add 1 to the middle, the right, and to the left. Okay, so if we do that, we get 3x is less than 6 and greater than -4. And if we divide everything by 3, left, middle, and right, we get -4/3 is less than x is less than 2. So with less than, again, you want to treat that as a compound inequality. Now in greater than, okay, when you think of and, okay, less than, you think of and. When you think of greater, you think of or. So what you would do for this one is you'd say x plus 1 is greater than 4, or x plus 1 is less than -4. Okay, so see what I did there is I flip the sign to the opposite, and I flip this number to the opposite as well. So x plus 1 is greater than 4, or x plus 1 is less than -4. So if we subtract 1 from both sides, we get x is greater than 3, or subtract 1 from both sides, or x is less than -5. So this is the answer here, both of these together. So greater than is an or, less than is an and. I'll have a link to more problems that I did for this one. This is a kind of a challenging concept, so you can see the video I did on that. I go into more detail. But number 12, here it just asks us to solve this compound inequality. This is very similar to the one we just did right here. Again, our goal is to get x by itself in the middle. And the way we do that is we add 6 to the left, middle, and right. Okay, so now we're down to 3x is less than 30, but greater than or equal to 18. And then we divide everything by 3 because we're just trying to get x by itself. So we get x is less than 10, and x is greater than 6. So 6 is in between 6 and 10. Okay, number 13, we're talking about domain and range, and we're also talking about, is this relation a function? Now remember, a relation is a pairing of two sets, an input and an output, an x and a y, a domain and a range. So the key here is the domain are the x values, so that's going to be -4, -1, and 5. So -4, -1, and 5. You could list them like that, or you can use these set brackets, and ideally you want to put them from low to high. Okay, and then for the range are the outputs. Those are the y values, and again, same thing, -3, -3, and 2, but since -3 is listed twice, I'm just going to write it once. Okay, you don't have to write it twice, you just list it once. And again, low to high is ideal. But part B said, is the relation a function? Now remember, not every relation is a function. A function is, for a given input, there's only one output. Again, I always like to use the example of a vending machine. You go up to a vending machine, you say, I'm going to have something to drink. You press A3. If one time a Coca-Cola comes out and the next time a Mountain Dew comes out, do you know what you're going to get? No, you really don't know. You just press that button, but it's unpredictable. So you only want, for every input, you only want one output. So let's take a look. So when I put -4 in, I get -3. When I put -1 in, I get -3. Now some students will think, well, this is not a function. They say, well, wait, you got -3 twice. What you don't want is you don't want the same input going to two different outputs. So if I had -4 goes to -3, and then over here I had -4 goes to 7, I would have that same input, -4, going to two different outputs. And that's unpredictable, right? You don't know what you're going to get. It's okay to have the same input, different inputs going to the same output. That's okay. You could press A3, get a Mountain Dew, or press A7, get a Mountain Dew. You know what you're going to get. when you press those numbers, because there's only one output. And then again, 5 goes to 2. So in this case, yes, the domain, the relation is a function. So we're going to say yes for that one. Okay, question number 14 says, which function is not linear? So remember, linear means it's like a straight line. Okay, now when you look at letter A, x squared minus 3x plus 2, you see this squared second degree equation. That means that this is a parabola like this, and that means it's not linear. So this one's not linear. Letter B, you can see this is in the form y equals mx plus b. That is a straight line, so we're going to say yes for this one. And then for letter C, h of x equals 4. That's like y equals 4, that's a horizontal line like this, okay? And so this one also is linear. So the one that's not linear here would be the first one, the x squared one. Okay, number 15, it says find n. So the line through negative 4, 6, comma 2n has a slope of 1, 6. Well, what you can do here is they're testing us on the slope formula. Remember the slope formula, y2 minus y1 over x2 minus x1. It's the rise over the run. So if we do that, let's see, let's do 6 minus n, y minus y over x minus x. Now the order is important. You want to make sure that if you make this point number 2, this is point number 1, or you can switch it around. This is point number 2, this is point number 1. And we're going to set that equal to 1, 6. Now what I'm going to do here is I'm going to cross multiply on the diagonal, okay? So if we do that, we get 36 minus 6n equals, now this is negative 6 times 1 is negative 6. And then if we subtract 36 from both sides, we get negative 6n equals negative 42. Divide by negative 6, and you can see that n is equal to 7. Okay, the next one, number 16, says, are the lines parallel or perpendicular? Now what they're testing us on in this problem is, do we know the slope? And if the slopes are the same, that means they're going up at the same rate, and that means that they're parallel. If the slopes are opposite reciprocals of each other, meaning they're the opposite sign, one's positive, one's negative, or vice versa, and the reciprocal, you flip it over. Okay, so it's a combination of those two. So we're going to use a slope formula like we did up here, and let's go ahead and do that. So 1 minus 2 is negative 1 over negative 2 minus negative 6. When you subtract a negative, it's like adding a positive, so that's going to be 4. So that has a slope of negative 1/4. Over here, 9 minus 5 is 4 over 3 minus 2, which is 1. And you can see this is a negative, this is a positive, and the one is the reciprocal of the other. So that means that these two lines are perpendicular. If they were both negative 1/4 or if they were both 4, they'd be going up at the same rate and they would be parallel. Okay, so that's talking about slopes. Number 17 asks us to graph this line, and the easiest way to graph this line, in my opinion, when it's in this form, is to make a table, set x to 0 to find the y-intercept, set y to 0 to find the x-intercept. So if you set x to 0, I'm covering this up because 0 times anything is 0, divide both sides by negative 6, you can see y is going to be negative 3. And if you set y to 0, 0 times anything is 0, I'm covering that up, divide by 3, x is going to be 6. So if we plot those points, 0, negative 3, and 6, 0, all we have to do is get out a ruler and draw a line through those 2 points. Okay. The other way to do this is to rearrange the equation by solving for y and put it into the slope-intercept form, the y equals mx plus b form. If any of these concepts seem challenging to you, I did a video on Algebra 1 final exam, and it talks about some of these concepts. It's a giant Algebra 1 exam review. You can check that out on my channel if you're interested. But let's keep going. As we go through these problems, we're going to get more challenging. This is write an equation of a line that passes through 1, negative 3 and has a slope of negative 2 in slope-intercept form. So remember, slope-intercept form is the y equals mx plus b form. We have to find the slope, we have to find the y-intercept. Well, they tell us the slope is negative 2, so let's put that in for m. Now we have to solve for b, and you can see they're giving us y is negative 3 when x is 1. So if we solve this, we get negative 2, okay, here, and if we solve for b by adding 2 to both sides, you can see that this comes out to b equals negative 1. So all we have to do is put that back in here, and we've got y equals negative 2x minus 1, and that's the equation of our line. Okay, question number 19. If you're enjoying this video, by the way, give it a thumbs up so I know to make more videos like these in the future. But it says write the equation of the line that passes through the point 4, negative 3 and is parallel to y equals 1/2 x plus 1 in point slope form. So the last question we did, number 18, was slope intercept form. But remember, point slope form is y minus y1 equals m times x minus x1. Now x1, y1 is your point, m is your slope. So in this case, if it's parallel, we know that it has the same slope as this line. So that means that m is going to be 1/2. And if it goes through the point 4, -3, this is going to be x minus the x coordinate of the point, y minus the y coordinate of the point, but this negative and that negative cancel and give you a positive. Okay, so this is your equation in point slope form. Number 20 says write the equation of the line that passes through -2, 5, and 6, 4 in standard form. Now remember, standard form is ax plus by equals c. Okay, so you get the variables on the left, numbers on the right. A, B, and C are integers, and A is positive. So that's the key for standard form. But what we want to do is let's start with either point slope form or slope intercept form, and then we'll convert it into the standard form. So first thing I'm going to do is I'm going to find the slope. So 4 minus 5 is -1. 6 minus -2 is 8. So we know we have a slope of 8. And let's just take this point over here. We've got y minus the y coordinate, x minus the x coordinate. See, the two negatives cancel. Now we've got it in point slope form. We want to convert it into slope intercept form. So I'm going to distribute the -1/8. So that gives us, let's see, -1/8 x. Let's see, minus 2/8. This is y minus 5. I'm going to clear the denominators by multiplying through by 8. So that's going to give us 8y minus 40 equals -x minus 2. I'm going to get the variables on the left, so I'm going to add the x to this side. So we get x plus 8y. And then I'm going to add the 40 to both sides, so that's going to give us 38. Okay, now you can see this is in standard form because we have the variables on the left, the coefficients, the a, b, and c are integers, and the a value is positive. If this was negative, I'd multiply through everything by a -1. Okay, let's go to number 21. It says if your starting salary in 2019 is $48,000 and it increases by $5,000 per year, write an equation that gives your salary t years after 2019. Now, sometimes students get a little bit confused by this, but if we're starting at 2019, that's like year 0, that's our initial condition, which is the 48,000. So if we use the slope-intercept form, y equals mx plus b, that initial value, that starting value, is 48,000. The slope, that's the rate of increase or decrease. In this case, your salary is going up by 5,000 per year, so the m value is going to be 5,000. Instead of x, I'm going to use t for years. Instead of y, I'm going to write S for your salary. Okay, so again, slope-intercept form on that one, just in a story problem format. Number 22 says the number of miles m that you can bike varies directly with the number of hours h spent pedaling. You can travel 30 miles in 4 hours. Write the equation relating m and t, and then how many miles can you bike after you pedal for 7 hours. Now, what they're testing us on in this question is the form of the direct variation. So y equals a times x or y equals k times x. It depends how your book writes it, but a or k is called a constant of variation, or you can think of it like the slope. So what we would do is we'd set this up as m miles equals a, or constant of variation, times t. And they give us a little hint. They say you travel 30 miles after 4 hours. Now if I divide both sides by 4, a is 7.5, so our equation is going to be m equals 7.5 t. So now we have a direct variation equation that relates the time pedaling and the number of miles traveled. Okay, and part B says how many miles can you bike after 7 hours? All we have to do is put 7 hours in for t, and we got it. So I'll go to the calculator on that one. See, 7.5 times 7, 52.5 miles. Remember, with story problems, you always want to put your units. Okay, 52.5 miles. Okay, question number 23. Tell whether the table shows direct variation. If so, write the equation. Now remember, direct variation are equations that are in the form y equals a times x or y equals k times x. But what I want to show you is if you get this a by itself, by dividing both sides by x, what you'll find is that if you divide the y value by the x value and you get the same quantity each time, that tells you it's direct variation. So let's test that out. If we do -36 divided by -9, what do we get? 4. What's -12 divided by -3? 4. 12 divided by 3, 4. 4, 4, 4, 4, right? So that tells us that y is equal to 4 times x. Now you can always test it out, put a value in for x. 4 times 15, yep, 60. You got it. So I have more examples like this of all these problems on my Mario's Math Tutor YouTube channel. So if you're having difficulty, go ahead and, go over there and see if you can get some other videos like that to take a look at, and I go through it in more detail. But let's go to number 24. So here what they have is us doing some graphing type problems. Here we're graphing an absolute value, here we're graphing an inequality, here we're graphing another inequality. So let's take a look at this. So the first thing we're going to do here is we're going to notice that this is in the form y is equal to a times x minus h plus k. hk is the vertex, so this is actually going to be a positive 3. The one group of the x here is the opposite sign, positive 3, and this one's going to be the same sign, positive 2. So I'm going to go right 3, up 2, that's the vertex. That's where the graph bends. Now remember, absolute value graphs have these V-shaped graphs, a real sharp corner there. Then if you look at the a value in front, in this case it's 1, okay, because there wasn't anything there, 1 times anything is itself, that's really like the slope. That's how steeply that the absolute value graph goes up. So in this case it's going up 1, over 1, up 1, over 1. You can go left and right because it's symmetric about that vertex. This is like a line of symmetry. Okay, so real easy to graph those. This one here, what I would do is I would do like we did some of the other graphs. We'd set x to 0, solve for the y-intercept, so you can see that's going to be negative 2. Set y to 0, divide by 2, that means x is going to be 4. Notice that it's less than but not equal to, which means it's going to be a dashed or dotted line. Then if we pick a test point, origin is a good point to pick, 0, 0. So if we put 0 in and 0 in, we get 0 is less than 8. Is that true? Yes, so where that point is, that's the true side of the plane. That's where we want to shade. If it was false, you would shade the other side of the plane. And then the last one, x is less than or equal to 3. Well, we know that x lines are going to be vertical lines like that. No matter what the y value is, x is always fixed at 3, but you can see it's equal to, which is why I drew it as a solid line. If it was just less than, I would have drawn it as a dotted line. And x is less than or equal to 3. Less than means that we're going to the left when it comes to the x value. If it was greater than, we would be going to the right. So we want the x values that are less than 3, meaning to the left, so I would shade this side of the plane. Again, you can do the test point method, put 0, 0 in. That's true, so you know you're shading the correct side of the plane. So I hope this is helping you so far. We've got a lot more questions to go through. A ton of information in here to help you with your midterm, or if you're just trying to review algebra in general. But number 25 says, write the equation of the parabola with vertex at the origin and directrix at x equals negative 2. Now I always like to draw a picture, just helps me visualize a little bit better. So that's the vertex. The directrix is at x equals negative 2. That's a vertical line. And so that means it's going to be opening away from the directrix. And the focus is going to be over here. It's going to be the same distance, we call that distance p, from the vertex to the directrix or the vertex to the focus. And in this case, you can see that p-value is 2. Okay, so the equation when it's opening to the left or right is going to be y squared equals 4px. If it opens up or down, it's going to be x squared equals 4py. So basically in this case, we can see we're looking at y squared equals 4 times 2, which is 8x. If it opened to the left, then this would be a negative 8, okay? So I have a lot of videos. I actually have a parabola playlist on my Mario's Math Tutor YouTube channel. If you want to learn all about parabolas, I would definitely go through those that video series. But number 26 now, this is another form of a parabola. This is basically called the general form of the parabola. It's in the form y equals ax squared plus bx plus c. And you can see that the a is 1, the b is 10, and the c is 3. And it says state the vertex, axis of symmetry, y-intercept, and graph it, right? So basically, when you find the vertex, this is the formula you want to remember. X equals negative b over 2a. That gives you the x-coordinate of the vertex. It also gives you the axis of symmetry, the line that divides the parabola in half. It's the same on both sides. So in this case, it's going to be the opposite of b, which is negative 10, over 2 times a, which is 1. So that comes out to 2. Negative 10 divided by 2 is negative 5. Okay, so negative 5 is our x-coordinate of our vertex. If we put negative 5 back in, we get our y value of our vertex. So if we do that, we get negative 50, positive 25, which is a negative 25 if you add those together, plus 3 is a negative 22. So that's our vertex right there. Axis of symmetry is going to be going through the x-coordinate of the vertex. That's x equals negative 5. The y-intercept is where the x-coordinate is 0. Okay, so if we put 0 in for x, you can see that the y-intercept is 3. Okay, and if we graph it, we can take this information that we've gathered, like the vertex, negative 5, negative 22, we'll just say it's way down here. Okay, the axis of symmetry, okay, divides the parabola in half. The y-intercept at 3, we do the mirror image over that line. Okay, now we've got some key points, you know, and we can sketch it real quickly like that. So that's graphing parabolas. Again, check out that playlist, Parabolas, on my Mario's Math Tutor YouTube channel. But we're going to be doing more problems like this. It's an important concept in Algebra 2. Okay, number 27, another parabola problem. But this parabola has been given to us in the form y equals a times x minus h squared plus k. This is called the vertex form. Remember, h comma k is the vertex. The A is what stretches the parabola vertically or compresses it vertically. If it's negative, it reflects and makes it open downward. But let's see, it's asking us for the vertex, axis of symmetry, y-intercept, and to graph it. So you can see the vertex is going to be at positive 2, comma 3. Remember, the one that's grouped with the x has the opposite sign. This k value over here has the same sign. The axis of symmetry is going to be through the x coordinate of the vertex, so that's going to be x equals 2. The y-intercept is a little bit more challenging. We have to set x equal to 0, because remember, when x is 0, we're not going left to right. We're going to be right on the y-axis. So if we put 0 in for x, we get 0 minus 2, which is negative 2. Negative 2 squared is 4, times 3 is 12, plus 3 is 15. And if we graph it, let's put all that information together. So the vertex is at 2, 3, right there. The axis of symmetry is x equals 2, like that. The y-intercept is way up here at 15, and if we reflect that over the line, meaning if you go 2 to the left, you want to go 2 to the right, that's also going to be at 15, and we can quickly get a nice sketch of our parabola. Now, number 28, this is the form of a parabola, but an intercept form. Okay, and it asks us for the x-intercepts, the vertex, the axis of symmetry, and to graph it. So here, what you do, this is like factored form. You set each of these factors equal to 0 to find the x-intercept. So if I set x plus 4 equal to 0, I get negative 4. And if I set x minus 2 equal to 0, I get positive 2. So those are the x-intercepts. So we'll just say negative 4 and 2. And then the vertex, okay, what we have to do is we have to find the axis of symmetry. Now the axis of symmetry is going to be halfway in between these two. And the easiest way to do that is just to add them together and divide by 2. So negative 4 plus 2 is negative 2, divided by 2 is negative 1, or you can just kind of count, you know, and find the middle like that. But it doesn't always work out to a nice round number. So that's why I did the midpoint formula. Add them together and divide by 2. So the axis of symmetry we said is x equals negative 1. And then now if you put negative 1 back in for x, you can get the y coordinate of the vertex. We've got the x coordinate. So let's put that in. Negative 1 plus 4 is 3. Negative 1 minus 2 is negative 3. If we multiply all that together, we get, let's see, we get negative 9 times negative half is positive 9 halves, which is 4.5, right? So that's at negative 1, 4.5. 1, 2, 3, 4, 5. 4.5 would be right about there. We've already got 3 points, so we can get a pretty good sketch of our graph like so. So again, you can go to that playlist I have about parabolas on my Mario's Math Tutor YouTube channel to learn all about parabolas, all the different forms. Definitely an important concept, especially if you're preparing for the ACT and the SAT. But let's look at number 29. This is what they're giving us here is what they call the vertical motion model. Vertical motion means, like, you know, going up and down in a vertical motion. You've probably seen this equation if you're studying physics or some of your science classes. But basically, t is your time. Generally, it's in seconds. The v sub 0 means the velocity at time 0, the initial upward velocity. And then this s here is the initial height, or the initial, you know, position. And the height is how high it is after t seconds, okay? So it's good to memorize this equation if you don't know it already, but a lot of times they'll provide it for you. So it says, find the height of a ball after 3 seconds that has been thrown upward with an initial velocity of 40 feet per second at an initial height of 100 feet. Well, let's see. So we've got h equals negative 16t squared plus 40t, because that's the initial velocity, plus the initial height of 100. And it says, find the height after 3 seconds. Well, that means we're just putting in 3 for t. Okay, so let me go to the calculator really quick, see if we can simplify this. So 3 squared is 9, times negative 16 is negative 144, right? Plus 40 times 3 is 120, plus 100 means that it's going to be at a height of 76 feet after 3 seconds. Okay, and you can check my math on that. Okay, letter B says, when will the ball hit the ground? Well, okay, one thing you'll notice is that this is a parabola, right? Because of the, see the x squared, the t squared. Parabolas have either a U-shaped graph, either opening up like this or opening down like this. But because the a value is negative, it means it's opening down. So basically what you can think about is this is going to look something like that. It's going to go up, it's going to come down, it's going to hit the ground. But the question is what's the height of the ball, okay, when it hits the ground? Well, when it hits the ground, the height is going to be 0. That's the key in this question. They don't come out and say it, but the height is 0. So if we set h equal to 0, let's do that here. We have our equation like this, and we want to solve for t. But notice this might not be so easy to factor. So what I recommend on a problem like this is just to go to the quadratic formula. Now remember, the quadratic formula is when you have an equation in the form ax squared plus bx plus c equals 0. Okay, that's the key. You want to give everything one side, set it to 0, and then our x value is going to be the opposite of b, plus or minus the square root of b squared minus 4ac all divided by 2a. And I've got more videos like this talking about quadratic formula on my Mario's Math Tutoring YouTube channel if you want to check out more there. But I'll just set it up for us right here. So this is going to be 40 squared minus 440 times negative 16 times 100 all divided by 2 times a. Okay, now one thing you'll notice is there's a plus or minus sign there. What does that mean? Well, it means that you're going to get two answers potentially. But let's see if we can simplify this. So I'm going to set this up here in the calculator. Negative 40 plus the square root of 40 squared, which is 1600. A negative times a negative is a positive. That's 64 times 100 is 6400, right? So let's just add that in there. Okay, let's see. All right, and I'm going to divide that by negative 32 because 2 times negative 16 is negative 32. So we get negative 1.5 seconds, but that doesn't make sense because that's like going backwards in time. Whoops. So basically what happens is you're going backwards. Okay, we don't want a negative time, so what I'm going to do is instead of doing positive here, I'm going to do negative so I can find this value over here. So let me go back to the calculator and let's see what that comes out to. So we get, okay, second entry, change this to minus, oh, we get 4.05 seconds. Okay, so that's going to be over here. So it's going to take time equals 4.05 seconds. So discard the negative answer. You just want the positive answer. In this case, letter C, it says, what is the maximum height? We're trying to find this point right here. Now, if you have a graphing calculator, of course you can graph it, find this maximum value. If you need help with that, you can check out my TI-83 and TI-84 tutorials on my YouTube channel. But the other way to do that is to use the negative b over 2a formula that we used earlier in this video to find the coordinates of the vertex. So negative b is going to be negative 40 over 2 times a, which is negative 16. And then what you're going to do is you're going to take that value, you're going to put it back in for t, and you're going to solve for h. Now I'm going to do it here now because I know some students are probably going to ask me what's the answer. So let me just see if I can figure it out real quick for us. Negative 40 divided by negative 32. 1.25 seconds, it reaches that maximum height. So I'm going to put 1.25 back in. So let me see if I can do that. Store under x value. We've got negative 16 x squared. You guys can check my math on this and make sure that I'm doing it correctly. Okay, and so it looks like it's coming out to 125 feet. So that's going to be your maximum height after 1.25 seconds, 125 feet. Okay, number 30, we're almost to the halfway point of this midterm review. So what do you think? Are you guys going to score well on the exam? Let me know in the comments below. So let's see, factoring now, right? So we've come to that part of the review. Well, first thing you want to do here is you notice it's a trinomial. You notice the leading coefficient is 1. What you want to do in a situation like this is you want to ask yourself what two numbers multiply to the last term, negative 12, but add to that middle coefficient. So in this case, we've got x and x, that gives us x squared, but what two numbers multiply to negative 12 but add to negative 1? That's going to be negative 4 and positive 3. Now the nice thing about factoring is you can FOIL it out and check to see if you get back the original. Okay, so let's go to letter B now. Now here what you notice is only two terms. The terms are separated by minus or plus. This is what's called a difference of two squares. When you factor a difference of two squares, you want to take the square root of both of these quantities. So square root of 25 squared is 5c, the square root of 81 is 9, and you make one of these positive and one negative. Again, you can FOIL this out and make sure you get back the original. Remember though, the first step in factoring is always the greatest common factor, so check for that first and do that first. I've got a really good video, it's about 20 minutes long, and it goes through all the different types of factoring. I'll try to see if I can put a link in that when I go to do the editing for this video, but it's called Learn How to Factor, and you can check that out on my YouTube channel, Mario's Math Tutoring. Now this one, we can use the trial and error method, or we can do splitting the middle term and factoring by grouping. I'm just going to head and use the guess and check method or the trial and error method and do the FOIL backwards. So I'm going to say, maybe 2x and 3x. That gives us 6x squared. And what two numbers multiply to negative 15? Well, let's see, the positive 5 and negative 3. So then what I have to do is check the inner product and the outer product. That's negative 9x, that's positive 10x. That adds up the middle term 1x. Of course, the last terms multiply to the negative 15, the last term, and then the two first terms multiply to the first term, so I know I've got it. So let's go to number 31, solving this equation. Well, the first thing you want to do is you want to get everything on one side of the equation, okay, the equal sign, and set it equal to 0. So I subtracted the 3d and I subtracted the 24 to get everything on the left and set it to 0. Then we're back to what we were doing up here, which is just a factor. and we say what two numbers multiply to negative 24 but add to negative 3? Well, that's going to be, let's see, is it going to be negative, no, it's going to be, let me see. What do we got here? 8 and 5, no, 8 and 3, that doesn't work. 6 and 4 doesn't work. So in this particular one, I would do the quadratic formula. So I've got everything on one side. I would do the quadratic formula, so I would do negative b, which is going to give us positive 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c, all divided by 2 times a. Now when I was creating this problem originally, I was intending for this to work out using factoring. But again, if it doesn't, that's what the quadratic formula is there for. And you can go ahead and simplify this to get the solutions to this problem. So I'll let you do that one. Post the answer in the comments below and you can check with each other to see if you got the right answer. And let's see, so find the zeros. So now what does it mean when it says find the zeros? Well, when they say find the zeros, they mean that the output, the y value, is 0. So you set this equal to 0 and you solve. And you can either do that by factoring and setting the factors to 0 or by doing the quadratic formula like we did up here. In this one, we can factor this to x minus 5, x plus 3, because negative 5x and positive 3x add up to negative 2x, but the negative 5 times positive 3 gives you the negative 15. Now, if we set each group equal to 0, we get x equals 5 or x equals negative 3, and those are going to be our solutions. Again, you can check by putting them back in to see if you get 0. But remember, finding the zeros just means set the output or the y value equal to 0. Now for number 33, we're getting into radicals now. Okay, so reviewing radicals, and it says to simplify. So square root of 3 times square root of 24 is actually what? The square root of 72. Now we try to divide out perfect squares, and ideally you want to divide out the largest perfect square, which in this case would be 36 times 2 is 72. Square root of 36 is just going to be 6, so this is 6 square root of 2. Now I've got a video, it's called Simplifying Radicals Easy Method, and that video is really popular. A lot of students have benefited from that, so you might want to check that one out. This one, what we want to do is we want to combine like terms, but you can see there's nothing in common. So if we simplify, square root of 32 is 16 times 2, square root of 16 is 4, so we get 4 root 2. So 20, we can factor out 4, square root of 4 is 2, so we get 2 root 5. So now if we look, we can see we can combine these. 3 square roots of 2 plus 4 square roots of 2 is 7 square roots of 2. Minus 2 square roots of 5. Now we can't combine these any further because these either have to be both square roots of 5 or both square roots of 2. They're different terms, so we can't combine them. This one here, 3 over 2 minus root 5, we want to simplify this, and when you're simplifying fractions like this, you don't want the radical in the denominator. So what you want to do is you want to multiply by what's called the conjugate. So what's the conjugate exactly? Well, it's the same thing as what we have here in the denominator, 2 minus root 5. But what you do is you change that sign from negative to positive, or if this was positive, you change that to negative. Now, when you have a binomial times a binomial, you FOIL. Here we have a monomial times a binomial. We just have to distribute. So let's go ahead and simplify. We get 3 times 2 is 6. 3 times root 5 is 3 root 5. In the denominator, what's interesting about multiplying by the conjugate is that the inside and the outside cancel. So negative 2 root 5 and positive 2 root 5, those cancel. We just get a first and a last. 2 times 2 is 4. Negative root 5 times positive root 5 is negative square root of 25. Square root of 25 is 5, but it's a negative, so it would be negative 5. 4 minus 5 is negative 1. If we divide both these terms by negative 1, we can simplify this to negative 6 minus 3 square roots of 5. Again, check out more videos on my YouTube channel about simplifying radicals. Number 34, it says simplify and write in standard form, a plus bi form. That's the standard form of a complex number. So we've got some more examples of radicals here, but you can see when you take the square root of a negative number, what do you get? Well, remember, this is very important. Square root of negative 1, we use the letter I to represent the square root of negative 1. So we could really break this down into square root of negative 1 times square root of 16 times square root of 3, because these all multiply to negative 48. The reason I did this is because 16 is a perfect square. Square root of 16 is 4. Negative 1, square root of negative 1 is I, so we get 4i square root of 3, okay? That's what it equals. And then over here, what we're doing is we're combining two complex numbers, a plus bi, we're subtracting these two complex numbers. So what we have is 3 minus 4, which is negative 1, and we have negative 5i minus 2i, which is negative 7i. Now what a lot of students like to do is distribute the negative, because subtraction is like adding the opposite, or distribute the negative, and then you can just combine like terms. But you always want the real first and the imaginary. Okay, question number 36, it says solve these equations. Okay, well, I'm going to do letter B first. It says 3 times x minus 1 squared minus 4 equals 11. Now what I'm going to do is I'm going to work from the outside in towards that x by doing the opposite. So what I'm going to do is I'm going to add 4 to both sides. so that equals 15. Okay, so you're with me so far. Divide both sides by 3, so that gives us x minus 1 squared equals 5. And then I'm going to do the opposite of squaring, which is take the square root of both sides. But remember, when you do that, you get two answers, plus or minus square root of 5. The square and the square root cancel each other out. And then if I add the 1, I get x equals 1 plus or minus square root of 5. And you want to add that 1 in front of the plus or minus. Okay, but going back to letter A, what I would do here is I would do a similar sort of a situation. I would subtract 2. So that gives us x squared minus 4x. And then what I'm going to do is I'm going to complete the square. So half of negative 4 is negative 2. Negative 2 squared is positive 4, but you want to add it to both sides to keep the equation balanced, right? If I factor this, I get x minus 2 squared equals 2. And then we're back to where we were at this step right here. So I want to take the square root of both sides. Remember, when you do that, you get two answers. You get x minus 2 equals positive root 2, and you get x minus 2 equals negative root 2. Then you can just add 2 to both sides of the equation, like so. And so you're going to get x equals 2 plus or minus square root of 2. Okay, so that's completing the square, and basically you're working from the outside in then after you complete the square to solve for x. Number 37 says find the discriminant and tell how many x-intercepts the graph has. Well, first of all, what is the discriminant? Well, the discriminant is the b squared minus 4ac. That's the part that's underneath the square root in the quadratic formula. And remember, this goes like this, a, b, and c. So if we figure out what b squared minus 4ac is, that's going to be 3 squared minus 4 times a times c. That gives us 9 minus 40, which equals negative 31. Now, here's the thing. When the discriminant comes out to a negative number, you get 0 solutions. And what that means is the parabola is not crossing the x-axis at all. If it comes out to 0, that means that you're getting one solution. It's touching right at the vertex. And if it comes out to a positive value, you're getting two solutions. It's crossing the x-axis at 2 points. But because this is negative, it really means that there's no x-intercepts. So it says determine how many x-intercepts. We're just going to say none. Okay. So going on to number 38, it says use your calculator to write a quadratic function that passes through these 3 points. Now there's a lot of different ways to do this. One way would be to write a system of equations, because you've got 3 variables and 3 unknowns in your y equals ax squared plus bx plus c. Another method is to use the quadratic regression feature on your calculator. By plugging in these values in your data and then going the quadratic regression, it'll calculate it for you. There's a lot of different techniques, but I think what I'm going to do is I'm going to direct you to the video that I did on writing the equation of a quadratic given 3 points. So you can check out that video for a little bit more information. See if you can do this on your own. I calculated this a little bit earlier here for us, and it looks like the equation should come out to y equals x squared. Let's see, where is it? Y equals x squared minus 3x plus 4. So that's what you should get. But if it's multiple choice, you can always try plugging the points in and making sure that it makes the equation true for all 3 points. That's another way to approach it. Now number 39 says simplify each expression. Okay, so here we're working with the exponents, negative exponents, and so on. So here we've got 3 divided by 12. 3 goes into 3 once, 3 goes into 12 4 times. So I just reduce. But when you subtract, what do you do to the exponents? When you divide, what do you do to the exponents? I gave away the answer. You subtract. Negative 2 minus 1 is negative 3, right? You put the answer in the numerator, and then over here, when you divide, you subtract 0 minus 3 is d to the negative third. Now, you don't want negative exponents in the final answer, so what do? Anything that has a negative exponent, you move it to the other side of the fraction bar. If it was down here, you move it up to the top. If it's in the top, you move it to the bottom. The negative is just telling you to take the reciprocal. Okay, so that's the idea for letter A. Now, for letter B, what we have is we have a power to a power. Now, what do you do when you have a power to a power? Well, you have to distribute that, okay, that power, and you multiply. So power to power, you multiply. So you don't really see it, but 2 is to the first. So 1 times negative 3 gives you 2 to the negative 3. Negative 2 times negative 3 is 6. 3 times negative 3 is negative 9. And same thing the denominator, that's 5 to the negative 3, and then y to the negative 6th. Okay, now remember, when you divide, you subtract. So if we have the same base, like here we have both base y, negative 9 minus negative 6 is going to be negative 3. So we get x to the 6th, y to the negative third. The 2 I'm going to bring to the denominator, the 5 I'm going to bring to the numerator, because the negative exponent tells you to take the reciprocal. So that's going to be 5 cubed up here, 2 cubed down here. Also the y I can bring down to the denominator because it has a negative exponent, and I'm going to simplify. So 5 cubed is 125, x to the 6, 2 cubed is 8, and then I'm going to bring the y down to the denominator, y cubed, and you got it. So testing us on negative exponents, really important. Now for this one, what I would probably do, a lot of students get a little confused about this, but I think the easiest way to do it is multiply the numerators together and the denominators together. So that's what I'm going to do right here. Okay, so I'm multiplying just horizontally across, okay. So that comes out to, let's see, and I like to put it in alphabetical order if possible. So that's the idea. And then you can see the 30s are just going to reduce to 1. 2 minus negative 2 gives you x to the 4th. 5 minus negative 2 gives you y to the 7th. And that's your final answer. So the key, I think, is to multiply the numerators together, denominators together, get it into one fraction. And when you divide, you subtract, okay, as long as the bases are the same. And then with the numbers, you just reduce. Okay, question number 40 says, write in scientific notation. So here's the thing, when you multiply, you divide, we're using the rules of exponents, but we're applying it to scientific numbers. So here, 1.8 divided by 3.6, that's actually 0.5, right? It's a half. But when you divide and you have the same base, what do? You subtract the exponent. So 4 minus negative 3 gives us 10 to the 7th. But you can see this is not in scientific notation. We have to move this decimal point so that there's just a single digit in front of or to the left of the decimal point. So when we do that, we actually are making this number larger by a power of 10. So to counterbalance that, we're going to subtract 1 from this power of 10 exponent, and that's going to make this 10 to the 6th. So that's number 40. Number 41, they give us this polynomial and ask us for the degree, the leading coefficient, f of negative 1, and to describe the end behavior. So first of all, the degree. Well, when you think of the degree, you think of the highest exponent, the highest power of x. In this case, 3 is the highest, so we're going to say it's degree 3, or you could say it's a cubic, okay? The leading coefficient is the one that leads it off. It's in front of the highest power term, the term with the highest power of x. So in this case, that's going to be a negative 4. So when you write it in descending order, that first one, that leading coefficient, that one on the left, that's the one we're looking for. And then f of negative 1 means we're putting negative 1, see whatever's in the parentheses here, we put that in for x on the right and we simplify. So if we put negative 1 in, negative 1 cubed is negative 1 times negative 4 is positive 4. Negative 1 squared is 1 times 2 is 2. Negative 1 times negative 5 is positive 5 and 8. So if we add all that together, we get 19. And then it says describe the end behavior. Now what they're saying here is, is a parabola, not the parabolas, but there's a polynomial going up to the right, down to the right, up to the left, down to the left. And it depends on your class and on your teacher. So I'm going to show you 2 different ways. One way is you could say because the leading coefficient is negative, it's going down to the right, but because it's an odd degree, that's going the opposite direction, up to the left. So you could say up to the left, down to the right. The other way to write this, a little bit more mathematical, I guess you could say, would be the limit as x approaches negative infinity, meaning as the x gets smaller and smaller as you go to the left, the y values, the f of x values, are approaching positive infinity. And the limit as x is approaching positive infinity, meaning as you're going to the right, as x gets larger and larger, the y values are going down, they're approaching negative infinity. So that's the limit notation. Okay, now, if you're preparing for the ACT or the SAT, check out my 2 courses, my huge ACT Math Review video course or my huge SAT Math Review video course. I go through a number of concepts that are covered on the test. We go through example problems, we go through formulas, there's a teaching section, there's opportunities for you to practice. There's 3 free previews for both those courses, so check out the free previews, see if it's something that you think that will be beneficial for you. A lot of students have already taken my courses and have reported back to me that their scores have gone up on those math sections of the ACT and SAT. So check those 2 out, and that'll definitely help you. But let's continue on with this midterm review. So number 42, it says simplify this expression. Now, a lot of students, they make the mistake of when they see this square here, they just square the 5 and they square the 2x. You don't want to do that, right? You want to think of this as a binomial, which means 2 terms, squared, which means you have 2 of them, like that. So what I probably would do is I would FOIL these out first. So let's do that. 2x times 2x is 4x squared. The outside is 10x, the inside is 10x, that's 20x. And then 5 times 5 is 25. And then we're multiplying that all by x minus 2, okay? So what I would do is I would take the x, multiply all these by x, the negative 2, multiply all 3 of those by negative 2, and then combine like terms. So let's see if we can do that. So x times 4x squared gives us 4x cubed plus 20x squared plus 25x. If I distribute the negative 2, that gives us negative 8x squared. That gives us negative 40x, and that gives us negative 50. Now I lined them up in this way to make it a little bit easier so we could just add straight down. Okay, so that gives us 12x squared plus 15, minus 15x, minus 50. And you got it, right? Okay, so now number 43, we're getting into factoring. A little bit more challenging type of factoring problems. We did factoring earlier in this video, but here what we're looking at is a difference of two cubes. So remember, when you factor a difference of two cubes, this is the formula that you want. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Now, if you're adding two cubes, it's going to be plus minus plus. A lot of students remember this acronym SOAP, and what it stands for is the same. So if you're subtracting, you're subtracting. If you're adding, you're adding. It's the same sign. Then it's the opposite. So minus plus, plus minus. The last one, AP, stands for always positive. So think of the SOAP acronym as a way to remember the difference of two cubes and the sum of two cubes. But in this case, we can see that 64c cubed, this is really 4c. 1 cubed is the cube root of that's just going to be 1. So our a value is 4c, our b value is 1. So this is going to be 4c minus 1. 4c squared is 16c squared. 4c times 1 is 4c, and then 1 squared is 1. And you can't factor it any further. That's as far as you can go. This one here is what they call quadratic form. Okay, and quadratic form means that you would know how to factor this if it was in the form like a quadratic, like a m squared, right? See, imagine for a moment if it was like this and you were factoring. You'd say, what multiplies to 36 but adds to negative 13? That's negative 9 and negative 4, right? But this is m to the 6th. So what I'm going to do is I'm going to say m cubed and negative 9 and negative 4. See? And then the thing you have to be careful with is sometimes you can factor further, because they'll say factor completely. That means keep going, right? But the thing is first step is always to factor the greatest common factor. And then you can proceed from there, whether it's a difference of two cubes, difference of two squares, sum of two cubes, quadratic form. I talk all about all these types of factoring in my video, Learn How to Factor. So check that out on my Mario's Math Tutoring YouTube channel. Now this one, you see how there's 4 terms? The terms are separated by plus or minus. When you have 4 terms, what you do is you think about grouping, factoring by grouping. Okay, now there's a plus sign in between these. So then what you do is you factor out the x squared. That's the greatest common factor. Same thing here, you factor out the negative 4. That's the greatest common factor. But notice how we have an x plus 3 in common. If we factor that out of this group and out of this group, right, what are we left with? We're left with x squared minus 4. Now you can take a look at factoring by grouping on my YouTube channel if you want to learn more about this, but notice this is a difference of two squares, which means we can factor it further, x plus 2, x minus 2, and we just bring down the x plus 3. So with factoring, you always want to see if you can factor further. So that's important. Okay, number 44, it says given f of x equals negative 3x cubed minus 4x squared plus 1 to find the local maximum and the zeros. So these are calculator problems, and what you would do, and I've done videos on this before, you can go to my TI-83 and TI-84 calculator tutorials, but you want to find, the local maximum. Now the local maximum is going to be, where it's a high point, so where it bends, but you get like a top of the hill. So what you would do in your calculator is you would select a point to the left of that maximum, to the right of the maximum, and you would say calculate, and we would find that high point. So I calculated this a little bit earlier, and it's in this one, if you're doing this at home, you should get a local maximum of 0.18, so that's 0.18, comma, negative 0.73. Okay, so you can verify that on your graphing calculator. And then the zeros, what you're doing, same thing, you're trying to find out where the y-coordinate 0, meaning you're looking for where it crosses the x-axis. Again, you're going to pick a point that's to the left of that 0 and a point to the right of that 0. One should be above the x-axis, one should be below, and you would say calculate, and it would zero in on that particular 0. No pun intended, right? And so you should get for that one negative 4.37 comma 0. That's the location of that 0, that x-intercept. Okay, so let's take a look at number 45. So number 45, you're doing long division. Now, when you're dividing this polynomial by x minus 2, you could do synthetic division also. I guess I'll show you both ways. So let's say you're dividing by x minus 2. So this is x cubed minus 4x squared plus 7x minus 2. So you say, how many times does x go into x cubed? Well, it goes in there x squared times. Then you take the x squared and you distribute to both of these. So this is called, polynomial long division. I've got videos on this on my Mario's Math Tutoring channel. Then what you want to do is you want to subtract. Now what a lot of students do is they change the signs to the opposite. So they'll make this negative, this positive, and they'll add, because subtracting is like adding the opposite. So if you do that, these are going to cancel. You get negative 2x squared plus 7x minus 2. Okay, now how many times does x go into negative 2x squared? Well, that's going to be negative 2x times. If we distribute, we get negative 2x squared plus 4x. And then what you want to do is you want to subtract. What a lot of students do is they change the signs to the opposite and they add. So you can see we keep trying to cancel out that first term. Okay, then how many times does x go into 3x? That's 3 times. We distribute, we get 3x minus 6. Change the signs to the opposite and we add. Now what do we do with the remainder? We put the remainder over the divisor, what we're dividing by. And that's your answer. Now you might be asking, Mario, well, how do we do this if we do synthetic division? Well, let's take a look. So what you would do is you would say if we're dividing by x minus 2, you just put positive 2 here, okay? And you use the coefficients 1, negative 4, 7, and negative 2. Now if you skip any of them, like if you skip from x cubed to x, you skip over x squared, you put a 0 as a placeholder. But what you do is you bring down that first term, you multiply on the diagonal, and you add straight down. And then you multiply in the diagonal, and you add straight down. And you multiply in the diagonal, and you add straight down. This last number is a remainder. So we started off with x cubed. This goes down by 1 degree, so we get 1x squared minus 2x plus 3 plus 4 over our divisor x minus 2. And you can see they match. This is a little bit quicker, but this only works if you're dividing by a linear factor. And so if it's like x plus 2, this would be a negative 2. If it's x minus 2, it's positive 2. That sign changes to the opposite. So we've got long division, synthetic division. Number 46, it says list all possible rational zeros of this function. Now remember, rational means ratio, like a fraction. Sometimes it's called the P over Q method, or the zero root theorem, or the rational root theorem, something like that. But basically you take all the factors of the constant over all the factors of the leading coefficient. So all the factors of 5 would be plus or minus 1, plus or minus 5, all over the factors of the leading coefficient, which are plus or minus 1, plus or minus 3. So it can be any combination of the numerator divided by the denominator. So we could say 1 over 1, which would be plus or minus 1, 1 over 3, that's plus or minus 1/3, 5 over 1, which is plus or minus 5, or plus or minus 5/3. And you can put those in order from lowest to highest, but those are the possible rational zeros. What that means is that's where it crosses the x-axis, this graph, if you were to graph it. Those are the possible ones. Now for number 47, they give us two functions, f of x equals x squared minus 1, g of x equals 3x. And it says find f of g of x, g of f of x. This is called the composition of functions. And letter C, we're dividing two functions, we're stating the domain. So let's see if we can tackle this problem. What I would do for this one with the composition of functions is I would take this in steps. So g of x equals 3x. I'm going to replace g of x with 3x. Now the way functions works is whatever's in the parentheses goes in for the x on the right. So I'm going to put 3x, this whole thing, in place of where x was, right? So it's a substitution. Then if we simplify, we get 9x squared minus 1. Now this one is the reverse. We have g of f of x. So again, I would like to take it in steps. I'm going to take f of x, which is x squared minus 1. I'm replacing f of x with what it equals, x squared minus 1. And remember, whatever's in the parentheses in here for our g function goes in for x on the right side in place of x. So I'm going to put x squared minus 1 in place of x. So it's like a double substitution, you can think of it as. Then if I distribute and simplify, I'm going to get 3x squared minus 3. Okay, now letter C says g of x divided by f of x. So here what we have is 3x over x squared minus 1. Now that's our answer, but it says state the domain. Now when we look at fractions, we can never have the denominator be 0 because that's undefined. So what I would do is I would set that denominator equal to 0, take the square root of both sides. Remember, you get two answers, so that means that x cannot equal plus or minus 1. So the domain would be all real numbers except for positive 1 or negative 1. Okay, question number 48, it says find an equation of the inverse of f of x equals 2x plus 5. So when you find the equation of an inverse, the key is to think of f of x as y. And what you do with the inverse is you switch the x and the y and you solve for the new y. So you switch the x and the y, solve for the new y. So we have x equals 2y plus 5. What I'm going to do is I try to get y by itself. So I'm going to subtract 5 from both sides. I'm going to divide everything by 2. So if I write that over here, we've got y equals 1/2 x minus 5/2, or instead of y, you can use the inverse notation, the function inverse notation, so 1/2 x minus 5/2. So that's how you write the inverse of a function. Now number 49, it says solve this radical equation. Okay, so what we want to do is we want to get rid of the square root by getting it by itself on one side, okay, and then square both sides. So if I do that, I get x squared minus 4x plus 4 equals 2x minus 1, because the square and the square root cancel. Then what we want to do is we want to get everything on one side of the equation, set it equal to 0. Then if you can, factor it and set the factors to 0, or do the quadratic formula. So all I'm doing is factoring it. If I set the factors equal to 0, I get 5 or positive 1. Now the bad thing about solving radical equations is that you want to go back to that original equation, okay, the very starting equation before we squared both sides, and you want to put these values in to see if it makes it true. If it doesn't, you get a false answer. That's called an extraneous root, and you cross that one out. So what I'm going to do is I'm going to put 5 in here. 5 minus 2 is 3. 2 times 5 is 10, minus 1 is 9, square root of 9 is 3. So that one actually checks out. 5 is good. If we put 1 in here, 1 minus 2 is negative 1. 2 times 1 is 2 minus 1, square root of 1 is 1. Negative 1 does not equal 1. Therefore, this is extraneous. Cross it out. 5's our good answer there. Okay, number 50, it says evaluate. Now remember when it says evaluate, that means find the value. And what they're testing us on here are rational exponents, or what could be called fractional exponents. Ratio means like a ratio of an integer divided by an integer. Now remember, when you have a negative exponent, that says to take the reciprocal or move it to the other side of the fraction bar. The denominator is the root, the numerator is the power. So what we're really looking at here is the 4th root of 16 cubed, like that. So what number times itself 4 times is 16? That's 2. 2 cubed is 8, so this comes out to 1/8. The other way to do this is to take the 4th root of 16, 2 cubed is 8, and at the very end take the reciprocal. So the negative means to take the reciprocal. Here, the 3, the denominator, that's the root, so we're saying what's the cube root of 27? And then the numerator, the 2, that's the power we want to square. Okay, raise that to the second power. So cube root of 27 is 3, 3 squared is 9, and that's our answer there. Number 51 says simplify, assume all variables are positive. They're asking us to simplify this 4th root of this quantity here. So one way to do this is to break this down using a prime factorization tree. 32 is actually 5 2's multiplied together, okay? And x to the 8th that is 8 x's multiplied together, y to the 9th is 9 y's, and so on. But when you're taking the 4th root, you're looking for groups of 4 of the same number. So we've got a group of 4 there, that's 16. The 4th root of 16 is 2, but we have a 2 left over. That stays underneath the radical there. Okay, x to the 8th, we would have 2 groups, so that's going to be x squared. The y to the 9th, we have also 2 groups, but 1 left over. 4 goes into 9 twice, remainder 1. And then 4 goes into 18. Let's see, that's going to be 4 times, that's 16, remainder 2. So that's our way of simplifying. So the easy way I like to do it is just see how many times 4 goes into that exponent, and whatever's left over, that stays underneath the radical. However many times it goes in evenly, that's what comes out on the outside, that many. Number 52, it says solve this equation here. So what we want to do is we want to work from the outside in towards the x. So instead of multiplying by 2/3, I'm going to multiply by the reciprocal, 3/2. That way that cancels and just gives us x to the 5th. 18 divided by 2 is 9. 9 times 3 is 27. Now all we have to do is just take the 5th root, okay, the 5th root of 27, like that. Or you can raise it to the 1/5 power, because the reciprocal 1/5 is the same as taking the 5th root. So let's go ahead and go to the calculator on that one. 27 to the 1/5 power, or the 5th root, 1.93 approximately is what you should get. So if you're enjoying this video and you like my teaching style and you're preparing for the ACT or the SAT, the math section, check out my huge ACT math review video course or my huge SAT math review video course. There's a teaching segment. We do example problems together. There's formulas, there's tips and techniques that you can use to boost your score on those tests. There's 3 free previews. Check that out, see if it's something you're interested in. A lot of students have taken those courses and benefited and reported back that they improved their scores. So I hope you will also take advantage of that. But let's continue with this video here. It says if a classic car appreciates at 10% per year and is currently $23,000, in how many years will it be worth $40,000? So the equation that we're looking at here is A equals P, 1 plus R to the T. The P is the principal, or the starting amount. In this case, the car is worth $23,000. It's going up. That's why we have the plus here. If it was going down, it would be minus. The rate is 10%, which is 0.10, and then the T is the time, but we want to know when it's going to be worth $40,000. Okay, so here's the thing. We want to solve for T. When that variable is in the exponent position like that, that usually means we're going to have to take the log. Okay, so what we're going to do is we're going to work from the outside in towards that t. So I'm going to divide both sides by 23,000. So if I do that, I get 40 over 23 equals, I'm going to combine these together, that's 1.10 to the t. And then what I'm going to do is I'm going to just take the natural log of both sides. Okay, as long as you do the same thing to both sides of the equation, it keeps it balanced. And then what I'm going to do is I'm going to bring that t down in front. That's one of the properties of logs. That's called the power rule. So that's going to give you t times the natural log of 1.10. And then what I'm going to do then is I'm going to divide both sides by the natural log of 1.10 to get the t by itself. So divide by natural log of 1.10. Now let's go to the calculator and see what that comes out to. So let's see, we've got natural log of 40 divided by 23, all divided by the natural log of 1.10, and that comes out to 5.8 years. So that's what we're looking at. That's when it'll be worth 40,000, 5.8 years. Remember, you want to put your units if it's a story problem. Number 54, it says rewrite in exponential form. This is the logarithmic form, and the key here, in my opinion, easy way to do this is think about logs and exponential functions as inverse. Inverses of one another. So just like squaring, square rooting, multiplying, dividing, adding, subtracting, like that. So what I'm going to do is I'm going to raise both sides. I'm going to exponentiate both sides using base 4. This is log base 4. I'm going to exponentiate with base 4. Now what we have is an exponential form. So we've got 4 to the negative 2 equals 1/16, which we know is true because 4 squared is 16, and the negative, we just take the reciprocal to get 1 over 16. 55 is almost the exact same thing, except for it says rewrite in logarithmic form. What I would do in a problem like this is I would take the log base 3 of both sides, because these are inverses of each other. So now you get log base 3 of 243 equals 5. So that's the key to be able to switch back and forth between logarithmic form and exponential form. Now this one says evaluate, part A and part B. Now a little technique is if it doesn't say equal to x, I would set it equal to some variable, make it into an equation, and then what we'll do is we'll exponentiate both sides. You want these bases to be the same. I'm raising both sides or exponentiating both sides using base 8. So we have 2 equals 8 to the x. Well, remember, 8 is actually 2 cubed, right? 2 is like 2 to the first. Power to a power we multiply. So we get 2 to the 3x equals 2 to the first. If the bases are the same, that means we can set the powers equal. That's called the one-to-one property of exponents. So divide both sides by 3, and you can see that x equals 1/3. For this one, I'm going to exponentiate or raise both sides using base 5. So exponentiating and taking the logarithm, those are inverses of each other. 5 to what power is 1? Well, you can see if anything to the 0 power is 1, so in this case, it's just going to come out to 0. Number 57 says find the domain and the range. Well, here's the thing. Our basic log graph looks like this. Okay, it gets closer and closer to the y-axis, okay? But what does the minus 4 do to the graph? It has the opposite effect. It actually shifts it right 4. 1, 2, 3, 4. So now our graph's going to look something like this. Okay, it's shifting it right 4. So you can see the domain is going to be x is greater than 4, but not equal to, greater than 4, because this is the asymptote. It can't equal 4. And then the range, you can see that this goes down to negative infinity, gradually goes up to positive infinity. So the range is going to be all real numbers for the range. So I'll just say domain and range. Okay, question number 58 says expand. Now I have a whole video talking about everything you need to know about logs, so you might want to check that video out. But basically what we have here is we've got natural log of 3x squared minus natural log of 4y cubed. Now when you're multiplying, you add. So I could write this as natural log of 3 plus natural log of x squared minus natural log of 4 plus natural log of y cubed. Okay, I put that in parentheses because this whole thing is being subtracted. Then what we do is we bring down the powers in front of the logs, and then what I would also distribute that negative through. So the final answer should look something like this. Natural log of 3 plus 2 natural log of x minus natural log of 4 minus 3 natural log of y. So that's fully expanded. Now number 59 says condense, so we're going the opposite direction. So I would bring the powers, the coefficients up as powers first. So this would be log of 7 minus log of x cubed minus log of y to the 4th. Now anything that you're subtracting is going to go in the denominator. You're going to be dividing. So this is really like log of 7 divided by x cubed y to the 4th, like that. Okay, number 60 says evaluate. Now this is a good opportunity to show you the change of base formula. What you do is you pick a new base. Okay, in this case I'm picking base e. And what you do is you could pick log base, any base, but the 50 goes in the numerator and the base 5 goes in the denominator. And so in this case, I just picked natural log, but it would be natural log of 50 divided by natural log of 5. Okay, number 61, and you would simplify. So let's see what that one comes out to. So we've got natural log of 50 divided by natural log of 5. And by the way, that's not the same as natural log of 10. That's sometimes students make that mistake. So you should get 2.43. Now, some calculators have the ability to change the base, but in this case, we're just using the change of base formula because some calculators don't have that function. So number 61 says 8 to the x equals 1/4 to the 2x minus 5. Now, one way to approach this problem is to use logs, but what we're going to do here is we're going to get the bases to be the same. So 8 cubed is really like, 8 is like 2 cubed, right? And 1/4 is really like 2 to the negative 2. But what do you do when you have a power to a power? You multiply, right? So basically what we have is we have 2 to the 3x power equals 2 to the negative 4x plus 10. Okay, so now that we have the same base, we can use the one-to-one property for exponents, which means if you have the same base, you set the powers equal to one another. So I'm just going to set those exponents equal. So that's negative 4x plus 10. I'm going to add the 4x to both sides and divide everything by 7. So we get x equals 10/7. You can put it back in and verify that the left side and the right side match. Okay, continuing on, we're solving for x in this equation, but this is a log equation. This is actually the one-to-one property for logs. So if you have the same base, you just set the arguments equal to one another, okay? And if I subtract the 3x from both sides, I get negative x equals negative 1, and divide both sides by negative 1, we get x equals 1. One thing you want to be careful of, though, when you're working with logs, is you cannot take the log of 0 or a negative number. That's just not possible. It's not in the restricted domain. But let's go ahead and put 1 back in. We get natural log of 2. 3 times 1 is 3 minus 1 is 2. Natural log of 2 equals natural log of 2. We're not taking the log of 0 or a negative number, so we're okay. This is a good answer. Letter C, though, is a little bit more challenging. We've got, let's see, I meant to write log base 4 on this one. But what we want to do is we want to combine these into one log first and then go ahead and solve this logarithmic equation. But remember, when you add, what do you do to the arguments? You multiply. Okay, so what we're going to do is we're going to multiply those together. We get x squared minus 9. And then instead of taking the log base 4, we want to exponentiate using the base 4. So I'm going to raise both sides using base 4. We get x squared minus 9 equals, because these are inverses, they cancel each other out, 16. If I add 9 to both sides, I get x squared equals 25. Take the square root of both sides, we get x equals plus or minus 5. But remember, you want to go back and check, because we can't take the log of 0 or a negative number. It has to be greater than 0. If we put negative 5 in here, we get log of negative 8. That's not in our restricted domain. If we put 5 in, that's 2. If we put 5 in here, that's 8. That's okay. So in this case, I'm going to erase the negative. It can only be positive 5. Okay, last question. You made it through this whole midterm review. Let's see if we can simplify this. We want to get the variable by itself. I like to think about working from the outside in, so I'm going to do the opposite operation. I'm going to add 4 to both sides. That's 20. Okay, and now we've got 3 to the 2x minus 1. Whenever the variable's in the exponent position like that, unless the bases are the same where you can use the one-to-one property of exponents, what you want to do is you want to take the log of both sides. So I'm going to take the log base 3 of both sides. These are inverses, they cancel. You get 2x minus 1 equals log base 3 of 20. Then you're going to add 1 to both sides. Okay, those cancel. Then you're going to divide both sides by 2. Okay, and you've got the x by itself. Now all you have to do is simplify and you got it. So I'm going to go to the calculator and simplify, but if this asks for an exact answer, that would be your exact answer. So let's see here. So we've got, I'm using the change of base formula because this is an older calculator, so I can get the same thing that you guys are getting, and then plus 1. And my other calculator is in my car right now. So that comes out to 1.86 approximately. And the nice thing is you can always, plug that in, approximately 1.86. Into x and just make sure that you get about 16. So this has been a whirlwind tour to help you prepare for your midterm, for Algebra 2, the first semester, or if you're just trying to brush up on your algebra skills in general. I also remember I have that Algebra 1 final exam review, which goes over a lot of Algebra 1 concepts. There is some overlap between the two courses, of course, especially at the beginning. So you might want to check that out. But again, I hope you enjoyed it. I hope you benefited. I hope you get a good grade on your test. Subscribe to the channel. Give this video a thumbs up if you enjoyed it. Comment below. Let me know, how you did on the exam. And I love to hear from you. And then also check out more videos on my Mario's Math Tutor YouTube channel. If there's anything in here that was unclear, I've got videos on all these different topics. I look forward to helping you in the future videos, and I'll talk to you soon.